Okay, so today we're going to start off with just some trigonometry, and what we're really going to look for here is how to work with this and connect the unit circle and the right triangle. Okay, so if we think back to geometry, we defined sine, cosine, and tangent, and there are three other ones which we'll obviously get to, but the sine, the cosine, and the tangent is for these. We want to define them in terms of the adjacent side, opposite side, hypotenuse. So you might remember like SOHCAHTOA, things like that. So we know the sine of x is the ratio of the opposite side length divided by the hypotenuse. And then the cosine of x is the adjacent side divided by the hypotenuse. With both of these, if we think back to a right triangle and the adjacent and the opposite and the hypotenuse, before we go on here, I wanted to point something out. If we look at a triangle, a right triangle, right, obviously we have a right angle, that makes it a right triangle. We're calling one of these angles x. Okay. Now, and then when you're doing this, well, x is going to be one of your two acute angles. So then with this, if you think about bisecting the angle, right? If you bisect the angle, it's going to hit the opposite side. Okay. If you look, the side that's opposite the right angle is always called the hypotenuse. And then the side that helps form the angle x with the hypotenuse, we call the adjacent side. And just to be aware now, if x was instead up here, right, the adjacent and the opposite would switch places. Everybody recall that? I'd hate for someone not to remember that and then make it a rough day, right? In pre-calcville. So the one thing I wanted to point out before we talk about tangent is we know that in a right triangle, the hypotenuse must be the longest side, correct? You can't build it otherwise, because if you did, you'd have a right angle and an obtuse angle, and that can't happen because it's more than 180 degrees. But what you'll notice is these two ratios, and this is always something we can stick with, they're always going to be, they're never going to be bigger than 1, right? The smaller numbers should always be larger, right? And then when we do some unit circle stuff, sometimes they'll both be 1. Sometimes you will get 1 here. When we start doing signed ratios, sometimes you'll get -1. But they're always going to be between that -1 and +1. So if you ever get that the sine is 3, check your work. Something's wrong, or maybe you forgot to include the hypotenuse. It's usually what people do. Okay, so just something to kind of think about there. And then the tangent of x is the opposite over the adjacent. Right? And this is, when I learned it, they would talk about the SOHCAHTOA. It's still out there because I'll see it written at the top of the page. But if you forget, sine's the opposite over hypotenuse, cosine's the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. Now, for our first little question we're given here is we're given this following picture. Okay, so we'll just use the same picture because we got a nice one here. And on our worksheet here, which is linked on the agenda, we're asked to use the Pythagorean theorem to find x exactly. So we have x over here, and actually this is not x anymore. There's no angle given. And the hypotenuse is 1. And then so here, because there's no angle named, you might refer to it maybe as like the horizontal side and the vertical side, or there's not. And then, of course, the hypotenuse is still the longest one. This type of problem where we're solving for x, we're going to do this a ton. We're really going to have to get comfortable with working with fractions, and a lot of times fractions with radicals in them. Very, very big deal for us. So it asks us to use the Pythagorean to find x exactly. Why don't you take a second and try that, and we'll see how that goes. Okay, so with this, if we're going to try to solve for x, using the Pythagorean theorem, we are going to just take one of the two legs and call it a. So we'll say maybe x squared plus radical 3 over 2 squared equals 1 squared. Just putting in the pieces here. Now, we think back to our radical rules. Where x squared, let's go up to here, just remains x squared. But if you have radical 3 over 2, anytime you have a fraction and you square it, you just square the top and you square the bottom. So radical 3 squared is 3. 2 squared is 4. And that's going to equal 1 squared, which is just 1. So here we have x squared equals, or x squared plus 3/4 equals 1. We're going to solve for x, so we're going to isolate x. We're going to do x squared equals 1 minus 3/4, which is 1/4. So for some of you, working with all the fractions is going to be a challenge a little bit. It's going to be something that you're going to get to refine that skill. Do you want to grab a paper off that back desk? It says 4.1 unit circle terminal point on the top of that bookshelf. So now we have x squared equals 1/4. We know to get rid of an x or squared, we want to square root both sides. Don't forget that it is going to kick out a plus or minus. Now, because we're solving for the length of a triangle side, negative doesn't make any sense, right? Negative doesn't, that's not a thing. So we're going to drop that, but I'm going to square root this, and just like when we squared a fraction, we squared the top and the bottom. When you square root a fraction, you square root the top and you square root the bottom. So square root of 1 is 1, square root of 4 is 2, and we'll get x equals plus or minus 1/2, but again, we're not going to use the negative, so we're going to get that x is equal to 1/2. Now, what we do later today, we're going to have to make the decision, do we keep the negative or do we keep the positive? It won't always be the same. It'll depend on this unit circle idea. Any questions here? Now, if this would have been a case where you would have, like, after here it was nice that we square rooted 1 and we square rooted 4 and they both worked out nicely, but say that you have that x equals plus or minus the square root of, I don't know, 3 over the square root of 5, right? Neither of those square roots nicely. We do want to rationalize the denominator, so we can leave the plus or minus, it doesn't matter, but we would say radical 3 over radical 5 times radical 5 over radical 5. So this would give us x equals plus or minus radical 15 over 5. So we don't want to leave, if you just have a number under a radical on bottom, we want to rationalize it. If you have something like a radical x or anything with an x involved in it, it's fine if you want to leave it in the denominator. It's kind of a general rule. Okay, so you wouldn't leave a radical 3 on bottom, but if you had a radical 3x, it's fine if you want to leave it. Or a radical x plus 2, it's fine to leave it there. So here is the unit circle. Right? This is like, for trig and pre-calc, if you can get a good handle on the unit circle and these basics we're going to learn the next couple weeks, the rest of the semester will be so much easier. Some of you will, unfortunately, will not get those basics, and everything will be a big struggle. Like it's like if you know, if we're doing a bunch of factoring problems and you don't know your times tables. It's like if you don't know the basics, it's really going to be difficult. So something I would suggest is maybe even grab a pack of flashcards. It would be a good thing coming up here. Not yet, but we're going to have some basic facts that we have to know. And then if we don't know, it's really going to be unpleasant moving forward. So with this though, a circle of radius 1 centered at the origin is called the unit circle. Okay, so if we think about this circle, if it has a radius of 1, this would be the origin 0, 0. This would be the point 1, 0, correct? This would, so for instance, this is 1, 0. Right, this is 0. There's, you know some points around it, correct? Would make sense. Its equation is x squared plus y squared equals 1. I don't know if you remember the formula for a circle back in geometry, but That's it. X squared plus y squared equals 1. Or maybe you remember x squared plus y squared equals radius squared for a circle centered at the origin. Okay, all of our trigonometric facts we can derive from this circle. Okay, and it's more powerful than a triangle because a triangle we're limited by the number of degrees we can have. Right? The biggest angle you can have in a triangle is less than 180. Right, and then it's a pretty weird triangle, anyways. And in a right triangle, the biggest angle you can have is 90, and then an acute angle. But we use this, we'll be able to do a lot of, well, all the angles, positive, negative, all kinds of neat stuff. So one thing we want to do here, this is just great algebraic practice too, is we want to show the point, which one is this? Radical 3 over 3, radical 6 over 3 is on the unit circle. Now, to do this, we need to do this algebraically. It's not good enough to graph a unit circle and be like, well, I know that radical 3 over 3 is about over here, and then you can't do that, right? Because even if it looks like it should be there, you can't eyeball it. We have to use algebra to do this. So what we're going to do to show that a point is on the unit circle is we're going to show that it satisfies the equation of the unit circle. So what we do is we take x squared plus y squared equals 1. We're going to put in radical 3 over 3, and really it's a check. We're checking, does it equal 1 is what we're looking for. If it equals 1, it's on the unit circle. If it equals anything else, I should want to put a question mark there. So here we're making sure that we plug these points in that we actually get 1. So it's basically a check. Now with this, if you take radical 3 over 3 and square it, well, square the top, gives you 3. Square 3 on bottom, we get 9. Don't reduce it. It'll be easier if you don't reduce it. Leave it unreduced here. For the next one, we have radical 6 over 3. You square radical 6, you get 6. You square 3, you get 9. Well, what's 3 ninths plus 6 ninths? 9 ninths, which is just 1, right? So it is equal to 1. It does check, which tells us that the point radical 3 over 3 and then radical 6 over 3 are both on the unit circle. Now, one reason that we really like the unit circle is if you think, I don't know, suppose that point is right here. Suppose that point is radical 3 over 3 and radical 6 over 3. Because with this, we squared both of these numbers, correct, as our first step. So would it have mattered if this was negative? If the radical 3 over 3 was negative and I squared it, would I still get 3 ninths? Sure. So what actually that tells us here, if you think about that, is that negative radical 3 over 3 and radical 6 over 3 is also on the unit circle. Okay. Or what if this would have been negative? Square it, the negative goes away. So that would give you radical 3 over 3, negative radical 6 over 3. And then here, the same thing. If they were both negative, when you squared them, the negative goes away. So something to note is that, you know, these points, they're different points. They're different ordered pairs, but they have the same two numbers. The only differences are the signs, the SIGNs, the positive or negative values. So that's something we'll see a bunch of. Okay, so with this one, the point radical 3 over 2y is on the unit circle and is located in quadrant 4. Now what that tells us, if we think back to this quadrant 4 piece, is if you remember our quadrants are labeled 1, 2, 3, 4. So we know it's going to be down here somewhere. Right? It'll be on the unit circle, it'll be on the arc, but it'll be there in the fourth quadrant. So what that tells me is I know the x value will be positive, which we see it is positive there. But what's it tell us about the y value? It's going to be negative. So we just have to keep that in consideration. Okay, so with this one, again, if it's on the unit circle, we know it has to fit the equation x squared plus y squared equals 1. We'll get radical 3 over 2 squared plus y squared equals 1. We'll square radical 3 over 2. So you square radical 3, you get 3. On bottom, you get 4. So now we have y squared is 1 minus 3/4. And then from here, we get y squared equals 1/4. So again, we're solving for y. We're going to square root both sides. So plus or minus 1/4 under a radical. Now luckily we know that the square root of 1 is just 1. We know that the square root of 4 is just 2. So we get y equals plus or minus 1/2, which is not, the correct answer is in there, but it's both not correct, because with this one, we said it was in the fourth quadrant, which we know the y value would be negative. So our answer here would be y equals negative 1/2. Okay, so the point radical 3 over 2 negative 1/2 is on the unit circle in quadrant 4. Does that make sense to us? Seem okay? All right, well, that's all we have there. On the back are just some practice problems. There's 6, confirm they're on the unit circle. Take the time to actually square them. It's really just to get you practice with fractions. And then find the missing coordinate, and then find the missing coordinate. So try those. I'd like you to try those before we meet again. I'm not sure if that's, I guess that's probably tomorrow.